Hello student, this is your 18th lecture of electrical machine 2. Today we are discussing about the construction and working of repulsion motor. So repulsion motor is a single phase commutator motor and operates on a principle of repulsion between two magnetic fields. Okay, so stator field or a field structure has a stator has a non-salient poles with slots, and it has a field winding of distributor type, and it is usually wound for a 4, 6 and 8 poles. The winding is supplied by a single phase supply AC supply and produces the main field. Okay, so rotor, now what about the rotor? Rotor is a similar to the DC motor. It has a drum type winding and connected to the commutator. Okay, so it is just like the DC motors. Then we have a commutator and brushes. The brushes are not connected to supply but are short circuited and remain in a contact with the commutator surface. Okay, so brushes are not connected to the supply are but are short circuited and remain in the contact with the commutator surface. The carbon brushes are short circuited by low resistance jumper and are used to conduct the current through the armature. Okay, so now how it works? When the stator winding is supplied by a single phase AC supply, an alternating field is produced, and this field induces EMF in a armature conductors by induction. Sorry. This EMF causes the flow of current in a armature. The direction of induced EMF is given by the Lenz's law. However, the direction of the currents induces in a armature conductors depends on the position of short-circuited brushes. Consider two-pole repulsion motor with its two short-circuited brushes. Okay, so consider one thing that if a brush axis is along the direction of the field axis. Okay, so if the brush axis is okay, so take this is the brush position, and if the brush axis is along the direction of field axis, this is the field axis n to s. Okay, so if both the axes are coincide each other, the angle between field and brush axis is 0. The direction of induced current will indicated as in figure 6.7. Okay, so this is the current direction. Okay, you can see in the current direction, these are the current direction for stator and rotor portion. Okay, then due to the current flowing through the armature conductor, it produces its own magnetic field. So definitely it will produce own magnetic field. You can see the upper portion has a plus sign and the lower portion has a negative sign. So it means that current inward and outward direction. Okay, so differently shown. Okay, it produces its own magnetic field with the poles as shown in figure. Okay, so these poles is formed. We have a man pole, we have a N and S, and now this is the pole formation for the rotor. Okay, the armature behaves like a electromagnet with the N pole is formed directly under the N pole of the main field, and S pole is formed in the direction under the S pole of the stator. Okay, so two poles are formed. You can see that here we have a one marking line. If we have an angle between the stator and rotor fields, then we have this S and N pole. Okay, so this S pole will have the repulsion with the N pole, and S pole has a attraction. Oh, sorry. Dissimilar poles are attracted toward, and similar poles are repulsion, have a repulsion. Okay, so definitely this S is catched by this N pole. This S pole try to catch this N pole, and this N pole try to catch this S pole. Okay, so we have a rotation in a clockwise direction. Okay, so this is the main principle of repulsion. Here we have a repulsion, and we have a repulsion between the light poles. Okay, so these two poles are similar, so they are got repelled. Okay, so if they repel, then it will rotate in a clockwise direction. Okay, so this is the basic principle how it works. Now, what is the advantages, disadvantages, and application? Advantage: it has a high starting torque, 3 to 4 times the full load torque. Relatively low starting current. The speed and torque can be controlled by brush shift. And disadvantage: because of brushes, the commutator, it requires some more maintenance. Possibility of sparking due to commutators and brush arrangement. Very high speed at no load. So if we run on the no load, then it has a very high speed. Poor power factor and motor is expensive. Okay, so application motor is used where we want a high starting torque and adjustable speed is required, like a machine tools, compressor, hoist, floor polishing and grinding devices. Okay, so these are some application of repulsion motor. Okay, so this is the end of your chapter number 2, which is a single phase induction motor. So if you have any doubt related to single phase induction motor, or we studied the two different motors, universal motor and repulsion motor in this chapter, same chapter. So if you have any doubt related to this chapter or this subject, then you can definitely comment it down in the comment box. Thank you.